and today we are going to be looking into a car price prediction model. So we are going to be using linear regression to predict a price of a used car. So we have this quicker data set. So since we are using Colab, we will have to upload our file into the we'll have to upload our CSV file into the files, and then from there we have to read it, and then using pandas. So here we have all the required libraries. We have pandas, we have NumPy, matplotlib, and a couple others. So right now in this particular step we'll be reading the CSV file that we have, and here into DF. So DF is the data frame, and we have this particular data set, which then gets converted into a tabular form. So if we do df.head, we can see all the columns and all the different rows that we have. So here we have name, company, year, the price, kilometers driven, and the fuel type for that particular car. So if we do df.tail, we can also see the last 10 data points of that particular data set. So and over here, if when we do df.info, we can see all the different columns and non-null count and all the data types. So in this case, for year, price, and even kilometers driven, it's all object type. I believe these particular data sets should be in categorical. So that would be our challenge to convert these into numerics. Okay. So yeah, again we would be doing a df.describe, which gives us the count, the unique values, the top and the frequency of all the categorical data, since we have categories right now. So yeah, when we do df.types, it tells us the type, which is all object as of now. So now when we check for the null values, we do is null and sum it up. So based on all the different categories we have null values in kilometers driven and fuel type. So yeah, we'll have to handle these null values. Okay, so in unique, when we want to check the different types of data we have, in names we have around 525, etc. So yeah. So in fuel type we have 3. Got it. So now we have to see whether what all issues we have in this particular data. So this data set basically has issues like the kilometers driven, year, and price have to be in integers and not in categories. There are null values, and the name of vehicle also need to be corrected, because if you see here, it's a very large name and we only need the first 3 words or something. The rest of the data is fine. Oh yeah, also here in price we have ask for price, which should not be here. So yeah, we'll have to handle this as well. And also this 70,000 needs to be in numeric, so this kilometers has to go, and this comma has to be replaced. So yeah, let's handle that. So when we do df of your dot unique, we can see all the different datas inside the year column. So here we can see that there is a lot of non-year values which are not needed here, so we'll have to handle that. So in this particular case, we are handling that situation where we are only keeping the numeric values. So df will be df of year dot string dot is numeric. So we're only going to be keeping the ones which are numeric. So yeah, so after once this is done, we will check all the unique values. So from here we can see that there are no more those non-numeric values in the year. So now we can finally change the type to integer. Next we have to handle the price. So inside price also we can see there is ask price, which has to be removed. So in this particular case we will again assign df equal to df of price and not equal to ask for price. So we will handle that case. And also the commas have to be replaced by blank um, um, empty string. So we will be doing the same in this particular case by replacing commas with empty string and also changing the type in this step. Okay, so in this, with this, the price column will also be handled. Again, the kilometers driven, we have to check all the unique values. Okay, the values look good, but they need, okay, yeah, there is one petrol which needs to be handled. There has to be only numeric values in this column. So yeah, again, in this, we can split the data and get only the, so we can split it as kilometers and this particular value. So from that, once we split, we only get the first index, and again in the first index we have to replace the comma with a blank empty string. So once that is done, we have to also keep only the numeric. So yeah, this petrol part would be handled in this particular case. And also we need to change the type to integers. So yeah, I think the kilometers driven column should be handled with this. Okay, next is the fuel type. So so we have to handle all the um, em- um, empty null values inside fuel type. So we will use is NA, and this should be able to help us with handling that. So next, after all of this data pre-processing, we can check the shape. The shape of our data is currently 816 rows and 6 columns. Yes, I think it's come down from the original number of columns which we had. We had around 892 columns. So right now it is only 816. So let's check the head, and the head gives us okay, so we are only using the first three um, words of the name of the car, keeping the same company and the rest of the data. Now once we do df.describe, it's going to give us, and we include all, it is going to give us the count, unique values, and standard deviation, mean, and everything. So minimum data, maximum data, 25 percentile, quartile, this is the median value, and 75 quartile. So yes, yeah, so df is basically our data set. Okay, now once we have the clean data, we can send it to another CSV, so which can be later downloaded and stored. Okay, so there is a little thing that we have to notice in this price column, that most of the prices, in fact, even 75% of the data, 75% of the data is at 5 lakhs, if you can see, but over here the maximum data is at 85 lakhs, which is a outlier, and we can see that by plotting a box plot. So we have plotted the price column, and we are using a box plot, and with the help of a box plot we can see that there is one outlier which is falling very much out of the range, and that is over here. So we can exclude that particular data. So we will do df is equal to df of price, and we will only consider price values which are less than 60 lakhs. So in fact there's not many, but yeah, all of them come under 60 lakhs, so we'll just use that much. So now in this part we will be doing the EDA. If you can see, we have plotted the price against all the companies, and as you can see, for all the companies, these are the box plots, and there are a few outliers which can be spotted through this particular graph. Then there is a swarm plot. In this, again, the prices are plotted against the year of purchase, and you can see all the prices which lie. So for example, a car which was purchased in 2019, depending on all the other factors, is sold for these particular prices. Next, yeah, so we also have this particular plot in which we can see based on the kilometers driven, the prices of the vehicles. This is based on the fuel type, petrol, diesel, and LPG. We have all the box plots, including all the outliers, prices against the companies, and fuel type. Next, we need to define the categorical, the independent and the dependent variable. So X is all the independent variables and Y is the dependent variable, which is our price. So we can check the shape of Y, which only contains rows, which is 15 rows. And now we need to use train test split. So from model selection, we would be importing train test split, and we would be doing the same on our X and Y data. We are using linear regression in this particular case. So in this case, we are using encoding technique called one-hot encoding. And also we'll be using pipelines and column transformation. So we will import all that in this particular step. So now we need to create one-hot encoding. We have to encode our data, all the categorical data, for example, name, company, and fuel type needs to be converted into, it needs to be encoded. So we can call the function, and we have to fit the categorical data. So once we do that, this object will be created, and now you have to create a column transformer to transform all these categorical columns. So make column transform is the function, and we will be passing the categorical data, which is as here, and we can call the model, which is linear regression. And now we are making a pipeline, and in this particular pipeline we'll be passing the column transformation and also the linear model. So, and based on this we will fit the model through the pipeline. So pipe dot fit would fit the X train and the Y train automatically, as you can see over here. And then from there itself we can do pipe dot predict, and we would get our Y pred, and similarly the R2 score, as you can see. And yeah, and then what we have to do is find the best score. So for that we have created an empty list of scores, and we have I, which is in the range of 1000. So let's give this random state. So we need to find out the exact random state for which our R2 score, we get the best R2 score. So we need to pass the model and of course the pipeline, and we have to pass the column transformation as well as the model, and we have to fit the pipeline and again get the Y pred. So this would give us the R2 score accordingly. So now here with this we get the best random state, which is 433, and using the best random state we will get this particular R2 score. So yeah, so this is the best R2 score. In this next part we are passing values to our model. So this is our model, pipe.predict, and we are passing this data frame, which includes this is the name of the name of the car, this is the company of the car, year it was purchased, the number of kilometers it has been driven, and the fuel type. And then we wanted to predict a particular value, and this model is able to predict around 4,31,000 something, which is a fair enough value for it to predict. So we get our value, that means our model is working fine and it's able to predict a good price for the vehicle. Although a lot of training can be performed to enhance the performance of this particular model. Yeah. So that is it for from this particular linear regression problem for predicting a car price. Thank you.